Hi all, welcome to my YouTube channel. So today we will be discussing about tree data structure, and in tree basically we are going to understand the pre-order, in-order and post-order traversal of tree. So basically there are three lead code problems, so we can go one by one to all problems and we can discuss on that. So let us open this problem. So this is the first problem is this binary tree in order traversal. So we have been given root of a binary tree and we have to return the in order traversal of its node values. Similarly, the second problem is problem number 144, which is a pre-order traversal. So again, we have root of a binary tree and we have to return the pre-order traversal of its nodes. And the third is sorry, the I think both are pre-order. So one is post-order. So let me grab that question. So let me take it from here. So 145 is post-order traversal. So we have pre-order, in-order, and post-order traversal. So let us first go through each of them in deep and understand how it actually works. So let us start with pre-order traversal. So first we will write uh, pre-order traversal. Okay. So let us create a tree. So this is A, this is B, this is C, left, this is root node, this is left, this is right. And again, let us take D and E, and for this we have to take F. So for pre-order traversal, just understand this. So pre-order traversal is basically root, left, and right. So first we have to go through the root, then we have to go through the left part of the tree, then we have to go to the right part of the tree. So when we start, we will first reach out A. Okay, so let us do like this A. So A is the root, so we are there, and left subtree is this one. B, D, E is a part of left subtree. C and F is a part of right subtree. So we will break down this into smaller trees. Okay, so now B will become the root. Now B will become the root, so we'll print B here. Now D and E. Now next part is let us mark null nodes. So this is null, this is also null, this is also null, this is also null. Same thing with this and same thing with this. Okay, null, null. So we will start from A, we will go to B, we'll print that B, then we will go to the D. Okay, now we will check. Okay, D is again root. So we'll check it. Okay, D, that's fine. Now let us go through this. Null, nothing. We don't need to do anything. Then again we will come back to D. Then again we go back to B. We already printed B, so that's fine. Then we will come back to E. Okay. So E is there. Then we have null, so no need to print anything. Then we will come back to E. Then we'll come back to B, then we go back to A. A already printed as it is a root element. Then again we'll come here and we saw C. C is a root element, so C will be printed. Now we have left part and we have right part. First left part, we will traverse the left part. So F, we will first visit F. So F will be printed. Then again null will be there, so no need of printing anything. Again we will come back to F, again C, again null, and then we can traverse like this and we will finally come out of the loop. So this is pre-order traversal and this will be the definition of pre-order traversal. Okay. So this is how we will traverse a tree. So this is root node, this is left subtree, this is right subtree. So first we have to go through the root node, then left subtree, then right subtree. Same will happen again root node, left subtree and right subtree. Okay, so while building the logic in coding, we can use this part to resolve to solve pre-order traversal problems. So let us now let us now try to write a logic for this. So we can write a logic for this. So let us write a logic for pre-order. Okay. So we can do it in LeetCode only, but let's try to write it here. Okay. So we have root node provided. Okay. We have root node provided as well as the list is provided. Okay. List is provided. List. So first of all, we will check if root equal to null. If the root equal to null, we have to return. That's the basic condition. Okay. Now next part is okay. We will write one method like pre-order, something like this, pre-order, and in that we will pass the root node as well as the list. Okay, list of integers. In that we will write this logic. If root equal to null, we have to return. Otherwise, other than that, what we can do, we will basically take root first. So in the list, basically we will add list dot add whatever the root dot val. Okay. So root dot value, whatever the value is there, we will update that in the list, and again we will iterate pre-order. Again we will recursively call pre-order with now root as root dot left, and we will pass the same list again. That list will get updated. Now pre-order and root dot right. Okay, and list. So first it will add the root element, then it will iterate over the pre-order of the left subtree, and the at last it will update the right subtree. Okay, subtree. So we can go through the logic of this once we are ready. So let's jump into the code. Okay, so pre-order traversal. So let us try to write a code for this. So this is a tree node provided, and pre-order traversal, this is already a okay, this is already there. So what we can do here is let us create a first a list, because we need it in a list 1 2 3. Okay, in this particular thing it's written like 1 null and 2 and 3. Okay, so 1 and left part is null and right part is 2, two's left part is 3 and right part is nothing. So let us start with this problem. So we will create a list. So list, let me create a list. Okay, let me do one thing. Okay, list will create a list of integer. Uh, I don't know why my left arrow is not working, so let me do it here. Okay, let me copy paste this thing. Okay, list list of integer, we can call it as list, and it will be new array, new array list. So let me copy this. New array list with integer. Okay, with integer, and we can comment it out. Okay, this is where we will keep our updated list, means basically the traversal outputs. Okay, now we can create let us create one method, or simply we can write like this, pre-order, and in that we can pass the root comma list. Okay, that's fine. That's fine, and at the last we can return the list. Okay, at last we can return list. Now class solution, this is fine. Now we will create method. Okay, public, public, it will be its name is its name is pre-order. So let me create a pre-order. Uh, public void pre-order. In that we need to provide a root. So it will be tree node root. Tree node root will be provided as a parameter and list of integer, or we can mark it as like this list only. Okay, so this is what we created. Now we will check, start with root. If root equal to null, if it is null, then simply we, we have to return. Okay, we don't have to do anything. And if root is equal to null, now simply we will add the list dot add. Let us add what is root dot val. Okay, root dot val is from where? This is from there. This is constructor. So root dot val. Again we will call pre-order for left part and for the right part. Okay, root dot right comma list. Okay, this is how we are going to approach this problem. Now let us try to run this problem. So all four cases are accepted, and let us submit this problem. So it got submitted. Okay, it got accepted with complexity. Let us analyze the complexity. So time complexity is big O of n. Okay, that's fine. Now let us jump into the another part of this is like pre-order is done. Now in order and post order, and homework for you guys is to write a code for that. So now we will start in order traversal. In order traversal. Okay, so again we will create A, B, C, D, E, and F. So in order is like whenever we reach the node second time, we have to print that. Basically second time, when we will reach second time we can print that. And the basic funda with in order is it should be like left, root, and right. First we need to go through the left part, then at the right part, sorry, then the root, and then the right. So by this only we can say that A will be in the middle of that. So we'll start. Let's go into A. Oh, okay, we don't want to print it. B, we will go to the left part of this. C, D will be the left part. Here null, here null. Okay. So again we will come back D. So now we will print D because second time we approached D. Now again we will go. Again we will reach D. Now B. Why B? Because we are reaching it second time. We are traversing it second time. Okay, now again we will go to the right sub part, and then we will check left part, and then again we check right part. So we'll come back to E. So we'll print E. Then again we will come back to E after traversing the right, and then we will go to the B. So B already we already traversed B, so no need of doing that. Then again we come at A. Second time we are doing that, we are coming second time to A, then we will print it. Now we'll go to the C. First time we are going at C, so no need to print it. Then we will go to F. Left part, right part, both are null, so we'll again come back to F, so we will print F. Now again we will come back to F after traversing the right side, then we will go back to the C. Second time we reached C, then C will be there, and at last A will be there. So this is how in order traversal works. Okay, so same logic we can apply. First left, then root, then right. So basically what we can write, we will write something like this. in order method we will write, and we will go first root dot left comma list. Okay, then we can put like root dot well, mm, list dot add root dot well, then in order root dot right comma list. Okay, so this is how in order traversal works. Now let us focus on the post order traversal, and funda is left, right, and root. So till now I think you guys know how we can traverse the trees. It's basically on the which tree need to be traversed first, and when. So in case of post order, left subtree will be traversed first, then right subtree, and then at the last root. So if we are creating some tree like this, A, B, then D, then E, and then C, and then F. So first we will go A. Okay, this is root. Okay, leave it. This is also root. B is also root. That's fine. Again we will come D. D is also root. Left subtree null. Again root will come. Again right subtree null. Again root will come. So left right rule. So D will be printed. Fine. Now we'll go to B. Okay, B is a root. No, we will go to the right subtree. Right E is there. Okay, we will again go to the left of this. Nothing is there. Again we will come to E. Nothing is there. Again we will go to the right of E. Nothing is there. We will come back to E. Now we'll print E as it is a root. Now again we come back to B. Now we saw that we traversed B. B again we are going to B. So B will become root. Now we'll go to A. Okay, we will not print A because still we have right subtree to explore. So we'll go to C. Okay, we will not print C as of now because we still have left tree to explore. We'll go. We don't have left tree. We don't have right tree. Now we'll come back to E. So E will be printed. Then we will go to C. Okay, right subtree. Nothing is there. Again we will come back to C. So C will be printed. Again nothing is there. Only root is left. A is left. So A will be printed. So this is post order traversal. So we can use recursive approach to resolve this recursive approach to traverse through tree, and also so time complexity is basically big of n while, because we are traversing through this, and we'll updating the list one by one. So thank you guys. In the next video we will be discussing the solution of the uh, in order and post order traversal. Along with that, I'll discuss some more problems on the binary trees. So stay tuned for more updates. Please subscribe my channel. Thank you so much.